Hey everybody, this is Miss Moran and this is video 8 for our series and sequence unit. We're going to be working on writing our sequences in sigma notation and then we'll be evaluating them. So the three things we're going to be able to accomplish after this video is writing our arithmetic and geometric sequences in sigma notation, evaluating the sequences once they're in sigma notation, and then I'm going to show you how you can use your calculator to sum a series. Alright, so we have two steps that we're going to be taking here. We're going to be writing them in sigma notation. In order to do that, we need to write the explicit. So we're going to need to find the explicit. And in order to find the explicit, we have to determine what type of sequence we have here. So I'm given the sequence 4, 6, 8, 10, and I have to determine whether or not I'm writing an arithmetic explicit or a geometric explicit. So I notice here that I'm not multiplying by anything in order to go from 4 to 6 and 6 to 8 and 8 to 10. I'm actually adding 2. So I know that this is arithmetic. And since it's arithmetic, I'm going to be looking for a d value, and my d value here is 2. So this is really going to stress our brains to think back to both our arithmetic and geometric explicit formulas. So I know I'm going to be writing a sub n will equal the first term plus d times n minus 1. And I can choose to clean that up, or I don't have to. It's up to you. I'm going to go ahead here and expand it. So I have a sub n equals 4 plus 2n minus 2. So a sub n will equal 2 plus 2n. Or you may write that the other way, 2n plus 2. So in my sigma notation, okay, I'm going to write my explicit 2n plus 2. And I'm going to say n is going to start at 1, and it's going to go all the way to 12. So this right here, we've taken care of step 1, writing it in sigma notation. Now I'm going to evaluate it. So I need to know my sum formula, and my sum formula is n over 2 times 2 times a sub 1 plus d times n minus 1, and I'm looking for s sub n. So I'm going to substitute in all the values that I know. I know that my n is 12. I know that my a sub 1 is 4. I know my d value is 2, and then I've got 12 minus 1 again. So let's go ahead and simplify that. You can use your calculator to do so. And I got 180. Okay, let's take a look at the next one. For the next one, I notice I'm going from 3 to 6, 6 to 12, and 12 to 24. So this is growing at a much more rapid pace than the previous one. So I'm going to conclude that this is probably going to be a geometric sequence. If it's a geometric sequence, then I want to be looking for my r value. So my r value here is going to be 2. I'm multiplying by 2. So I'm going to write my explicit. So a sub n will equal the first term and 2 to the n minus 1 power. I'm going to go ahead and put that into my sigma notation. So I have n equals 1 all the way to 8 of 3 times 2 to the n minus 1 power. I'm going to be using my sum formula for the first 8 terms. My sum formula here is going to be a sub 1 times 1 minus r to the n over 1 minus r. So let's substitute everything in. That's going to be s sub 8 will equal the first term, 1 minus 2 to the 8th power, all over 1 minus 2. Go ahead and take a moment to try to find that in the calculator. And I found the sum of the first 8 terms to be 765. All right, let's take a look at the next one here. All right, so I'm looking for an explicit formula here, 32, 8, 2 and 1/2. So again, I see that this is rapidly decreasing, so I know that I'm going to have 8 divided by 32 is going to give me 1/4. 2 divided by 8 gives me 1/4. So I have a geometric sequence here with an r value equal to 1/4. So I'm going to write my explicit. A sub n is going to equal 32 times 1/4 to the n minus 1 power. Now I'm ready to write that in sigma notation. I'm going to go 32, 1/4. You may also use 0.25. And now I'm going to say, well, I'm starting at 1, the first term, and this says I'm going infinite. So I'm going all the way to infinity here. So it's geometric, it's infinite, and my r value is less than 1. So I'm able to use my infinite sum formula. So s is going to equal the first term times 1 over 1 minus r. So let's go ahead and find that one using the calculator. I'm turning it into a fraction, and I got s to equal 128 over 3. Okay, let's look at the next one. So here I've got 10, 15, 20, 25. I can see that I'm counting by 5. So I've got a arithmetic, and my d value equals 5. So let's write the explicit. A sub n is going to equal the first term plus 5 times n minus 1. I'm going to clean that up. A sub n is going to equal 10 plus 5n minus 5. A sub n is going to equal 5 plus 5n. So in sigma notation, I'm going to have n equals 1 all the way to infinity of 5 plus 5n. So now I'm looking at an arithmetic sequence that is infinite, and I am not able to sum an infinite number of terms for arithmetic because these are going to go up to infinity. So we're able to draw the conclusion after it's written in sigma notation that it is not possible to sum this because it's an infinite arithmetic. Okay, I would be able to sum this arithmetic, so I'm not going to say I can't sum it because it's arithmetic. I can't sum it because it's an infinite arithmetic. Because if I stopped at 10 terms, if I stopped at 100 terms, I could do this. But because I'm going to infinity, so infinite is very important. I also don't want to say that I can't sum it because it's infinite, because I have to include that it's arithmetic. Because if it was infinite and geometric, which our previous example was, I was able to do it. So it's very important that we're communicating correctly as to exactly why it's not possible to make this sum. Alright, so now I'm going to give you a quick overview of how to do this in your calculator. I know we all have different calculators, so we're going to have to work carefully on this, but we're going to first start by going to our menu, and that is going to be under, excuse me, it's going to be under second stat, which my calculator says list. It's the one over by the arrow keys. And you're going to arrow over to ops. Actually, you're going to arrow over to math. Okay, so under the math screen, you're going to go down to sum, which is number 5. Okay, and if you press enter, that should open up on your home screen. So it should say sum with parentheses. Okay, and now you're going to go ahead back to second stat, and you're going to go to ops, and you're going to get the sequence button. So now we're back into ops, and we're going to get the sequence key. So I'm going to call that to the home screen. And here is where some of our calculators were different, where some of you had this form that was vertical and you had to enter everything in, and others of you had this exactly on your home screen. So regardless, the first thing you want to enter is your explicit. Okay, so you've got your explicit, comma, the comma is above the 7 key, and then you're going to put your variable, which was x, another comma. You're going to put the start, which in many of these cases has been 1, n equals 1, and then you're going to put the finish, wherever you're stopping. So if you're stopping at the 10th term or the 200th term, it goes there. Okay, now this does not work if I'm trying to do an infinite sum. So an infinite sum has to be done by hand. But remember, the only time we can do an infinite sum is when we're doing a geometric infinite sum. So you only have that one case where this doesn't work in the calculator. So this is the form. We would go ahead then and you do not have to close your parentheses, but then you'd be able to hit enter and it should give you a numerical value. If you get something that's an error, then you want to consider whether or not you were allowed to use this formula in the first place or if you've missed any of your commas. So we will definitely work on the calculator more together, but this should be enough to get you started in how you can work through some of these tomorrow in class. Great job!